Okay, well, again, plugging this function into this equation, we obviously have to find y prime, we have to find y double prime, and it helps to write y prime and y double prime out. The derivatives are straightforward. Then we plug that into the equation. So here's our y double prime, and then 5 times y prime gives us this term and this term, and 6 times y gives us this term and this term. And all that has to add up to cosine of t. And this is kind of reminiscent of some of the algebra you do in partial fractions. Okay? And if you don't remember partial fractions, review it. You're going to need it in this course. You need it everywhere. It comes up all the time. Okay? So what do? Suggestion? We got to end up with cosine of t. Can't have any sine of t. How are we going to end up with a cosine of t? What's the condition on the parameters b and c? Well, we've got a cosine of t here, we got one here, we got one here, right? Don't those three then have to add up to cosine of t? Okay? So you got cosine of t, a cosine of t, everything else is a sine of t. And incidentally, all those are going to have to add up to 0 because you don't have a sine of t over here, right? That's the common sense of it, okay? Simple common sense tells us that c cosine of t plus 5b cosine of t plus 6c cosine of t equals cosine of t. So, looks like that's 7c plus 5b has to equal 1.
6. Oh. Never mind.
And
Yeah.
do I have a bad sign on there? Something? Yeah, it's negative c, right? Is careless here?
Yeah. Yeah.
I'm never careless, but yeah, once in a while. Okay. Okay, so it should be 5c. Now, if I've done that right, and you see that already I'm being a little careless. Let me use a different color that contrasts better with the green that I use. Okay? Must still be the weekend mode or something. Of course, I'm always enjoying it. Okay, ready? So these three are sine terms, and there's no sine term over here, so it has to equal 0. So negative b minus 5c plus 6b has to equal 0. Now I haven't written the signs on these things, but it's clear from the fact that I underlined these in blue and those are signs. I could have written out the whole equation here, right? And you probably want to when you do it, but there's really no point. We have to see this in this equation, okay? So now we have two simultaneous equations. Okay? And those equations are easy to solve. You have the same coefficients. So I can well, okay. From this equation, now, different ways to solve the equation. I could add these two equations, right? If I add this equation to this equation, I get 10b equals 1, right? Okay? Now, if you don't know how to solve simultaneous equations or haven't done it in a while, make yourself a note. You got to know how to solve simultaneous equations, linear equations, okay? I'm not going to teach you how to do that. I'm not going to go through a lot of detail on how to do it. I expect you to know how to do it, or know with 10 minutes of review how to do it, right? If it takes you more than 10 minutes of review, which I don't think it will, then it takes more than 10 minutes, okay? But that's not like, you know, reviewing, as you will eventually need to do integration technique. It's going to take you a little while. Now, if you've reviewed what I asked you to review last week, which is your basic derivatives, your basic functions, and how to use a chain rule and stuff, okay? Then you've got that, and that's not going to be a problem, okay? But that, you know, that would, I figured that, you know, at least an hour or two on that.
Gotta shake the rust off.
Huh?
Gotta shake the rust off.
Yeah, yeah. You don't want the rust getting in your way when you're trying to understand the differential equations, okay? So anyhow, when you solve these, if you add these two equations, you find that 10b equals 1, so b equals 1/10. And if your prerequisite courses ask you what they were supposed to, which is rare, then you've done plenty of partial fractions, okay? Anyhow, b is 1/10, and c is negative 1/10. And that's because obviously b has to equal, b has to equal c. So, that's careless, b is positive 1/10. Because 5b minus 5c has to equal 0. b and c have to be equal. That's common sense, but if you got to use something besides common sense, you know, use whatever technique. Okay? Whatever technique works, I'm okay with it. Yeah, remember also, you're not just shaking the rust off, you're actually learning what you were supposed to have learned in the first place. Okay? You shake the rust off and you take it a little further because now you see it from a broader perspective. It starts to make more sense. Okay. Well then, now our solution, I'll write down our original equation, which was, no, I've got it written down there. Okay, so this equation has solution C1, how'd I write it? E to the negative 2t plus sine of t over 10 plus cosine of t over 10. Now, you plug this back in, and I'll probably ask you to do that for homework just as an exercise and make sure, but then I'll give you another one with something besides a cosine of t. Okay? Anytime I have cosines and sines of t over here, my trial solution, which is, my trial solution is going to be this. Because the same trial solution we just used, as some arbitrary linear combination of the sine and the cosine, because the only way you're getting cosines and sines out of this is by having cosines and sines in your y function. And you should see from this example how that happens. Okay? Now I'll probably ask you, I'm going to ask you right now, I'm not going to write it down. If you had an exponential function over here, what would that tell you? What do you take derivatives of to get an exponential function?
Let's go back to E.
Well, if the function is e to the 7t, what could you possibly take the derivative of to get e to the 7t?
7t.
Well, some multiple of e to the 7t. That's, you know, you're only going to get e to the 7t by taking derivatives of e to the 7t. So your trial solution is very simple. Just some number times e to the 7t. Now, if it was cosine t plus e to the 7t, then you would have to use a sine and a cosine and an e to the 7t in your trial solution. But it would all separate out. You know, what you get for the e to the 7t doesn't care about the sine and the cosine, nor do the sine and the cosine care about the e to the 7t. Okay? And it's really a pretty simple idea. You just have to know what you have to take derivatives of to get what you get. Now, if you got an arctangent over here, you don't even want to think about that right now. Okay? I don't really. Okay? Because the things you take derivatives of to get an arctangent are not the things you take second derivatives of to get arctangents. Okay? So, and my point there is, if you got arctangent of t over there, I think you're done. Okay? Now there's another technique, but it's much more challenging. Okay? This technique is really pretty simple, which is why I'm showing it to you in the first day of class rather than a month into the class. Okay? It actually occurs in chapter 4 of the book. But you can understand this much about second order equations, and there's a lot of the essence of second order equations here. And if you do this much, then the rest, except for that thing I talked about if you had a tangent over there or something, is just kind of window dressing. Okay? But there are a couple of deep techniques that you use. Reduction of order, integration by, I was going to say integration by parts. This is called undetermined coefficients. And there's this other thing called variation of parameters. The variation of parameters is a little more complicated. You got to have your, get your feet wet on a lot of things to do that, okay? So, on the homework, I'm going to ask you, I'm going to give you another equation, probably one with an exponential, probably one with something else that you're going to have to think about a little bit. Okay? Maybe you'll get it, maybe you won't. Not too hard, but one of those things that you give a class and you hope half of them get it. You hope all of them get it, but you kind of expect at least half to get it. Okay? Okay.